Advent of Code 2025, Day 4, Printing Department. So basically, we've moved on from the I forget where we were, but we've gone down the escalator, and we're in the printing department with all these paper reams, and we get a map. This is our first grid problem of the year, and it looks like this. And basically, the @ sign is the place where there are big reams of paper. And so for part one, all we need to do is figure out how many reams of paper have the forklifts can access reams of paper if there are fewer than 4 rolls around them. So there's 8 spaces around them, looking up, down, left, right, and diagonal. If fewer than 4 of those spaces have an ampersand in them, then they can be accessed. And so you can see they mark those with X's here, and we just have to figure out how many can be accessed. So let's go check it out. I will do a Genday script here for day 4. I go over how that works a little bit in day 1, but basically just pulls the input and makes me a stub. I better grab this and come down here and put it in the example, and we'll check out our input. I mean, it's much bigger, but 137 lines. It doesn't show me on a column, but it's big, but not not gigantic. So we should be okay. All right, let's process. So I already read in a list of lines. I could probably just work with that. I like, see if this bites me later, but I like working with like a default dict. Oops, not import default dict. And we can just do a real quick parse here. So we can say like grid equals default dict, and we can do it with bool. So like we're gonna have a default dict that takes a row and an RC pair, and it returns true or false. And so then we can just say we'll say r comma line in enumerate lines for c comma ch in enumerate line. If we'll say grid of r comma c is equal to ch is equal to boom, like that. And just like that, we've now got a grid that we can put in any RC and we can get back this. And what's nice about the grid here is that I can even ask like, what if off map, and it'll just return false by default. So by default if I ask anything that's not in the dictionary, it's just going to return false. So in fact, I can show this. Let's see. We do Python day 4. I like to use UV to run, but UV doesn't have this -I option. We'll do it. We'll do UV run day 4 example, and then we'll come here and breakpoint. Breakpoint. There we go. So we run this and we get to our PDB and we can say grid. So there's our grid. And if we do grid of like, what's an example that has something 0, 1, 2. So row 0, 0, comma 2, we should get true. Yep. If we do 0, comma 1, we get false. If we do 0, comma -1, we get false. We read off grid, it doesn't matter. So this saves us later from having to do bounce checks. So that's nice. All right, so now let's make a function real quick. Def count neighbors, and we'll just take R and C. This is not great because I don't love we're going to reference grid and we're going to not do this while I type it. We're going to reference grid and we're not passing it in. It's kind of sloppy, but for toy problems like this, it's certainly fine. Let's see. We will say count is equal to 0. We will say for dr in -1, 0, 1, for dc in -1, 0, 1, and then we'll say if grid of r plus dr, comma c plus dc, like that. That's all we have to check. Like if that's, oops, probably should put this here like that. So if that thing is true, and dr is not equal 0 or dc is not equals 0. So I don't want to count myself. I could start by setting count to -1 and assuming I only call count on filled spaces, but this feels more intuitive. And we'll say count plus equals 1. Return count. And there. So now we can count neighbors. So now I think this is pretty simple. We can just do sum, and we'll just do a loop here. So we'll say r comma c for r comma for what am I doing here? We're going to do 1 for r comma c in grid if count neighbors r comma c less than 4. That may be it. Let's get out of here. We'll do uv run example. Dictionary change during. Okay, so when I call count neighbors, I'm going to reference things off grid, and when I reference something in a default dictionary off grid, it's going to change its size. Let me put a break. I'll show you how we can work around this. So if we put a breakpoint here, and if we do grid, if we do like x for x in grid like this, when we treat it like a list, we're going to be getting back the keys, right? And so what this is saying is we're looping over the keys of grid, but the keys of grid are changing as we do it. And Python does not like that, and that's reasonable. So what if we just do list of grid? That'll get us the list at the start, and we can just loop over that, and that should be fine. Let's try that. Continue. I didn't need that breakpoint, and we have too many. We checked. We did not. That did not work. Let's see our example. Okay. So I guess it's time we troubleshoot. 19. It was supposed to be 13, right? Let's make sure of that. Yeah, 13. So let's do we can do a little print here. For r in len lines, for c in len lines 0. See if count neighbors of r comma c less than 4. If grid of r comma c equals false, print out. What are we doing here? We'll say out equals space. Elif count neighbors is less than 4. Out equals x. Else out equals ampersand. We're making the same chart they made. We'll do print out end equals that. And then we just need to print here, and we should print our grid. Let's see. We need int object is not. I do this all. We need to make that. We get the length. We need to get the range of the length. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so our grid looks perfect. Something is wrong here. Oh, I know what it is. We're doing if count neighbors, but we didn't check. We're checking everything. We're not checking only. So we really need if grid r comma c. That was a silly mistake. And count neighbors there. And that gives us the right answer. So I'm going to comment this out. We might want to come back to it, but we'll see. So let's run this on our input. 1480. All right, that took way longer than it should have, but let's go read part 2. All right, so for part 2, once the forklifts can access a piece of paper, they can remove it. And so then we can access more. And so they access basically just to iterate and remove. So in this case, in the initial state, we could remove 13 roles. Once they're gone, there's 12 new ones that can now be accessed and removed. Then there's 7, then there's 5, then there's 2, 1, 1, 1, 1, and eventually no more can be removed. These are all dense enough that they all have 4 attached. So the question is, how many can be removed in total? We're early enough in the competition that I feel like we can just sort of brute force through this. So let's give it a shot. We're going to come down here. Let's see. We're going to say, what are we going to say? Well, part 2 is going to equal 0 because we're going to have to track that in a loop. I'm going to come down and say while true. We'll figure out how to break later. And so we're going to want to do something where we say, we'll say next grid equal to defaultdict bool. And then we can say for r comma c in list grid if count neighbors if count neighbors of r comma c is greater than or equal to 4, next grid of r comma c is equal to true. So we're gonna set our next grid by basically looping through, and all the ones that won't get removed are gonna get set. And so now that we have our next grid, let's make a quick function that will count def count grid. So take grid, do default dict, and it will return an int. And all we're going to need to do here is return some 1 for r comma c in list grid if grid r comma c, like that. So that should, this is just a helper here, so we can call count grid and pass it any grid, and it should, what did I do wrong here? I got an extra thing. It'll count how many are true in the grid. And so now we can go down here and we can say part2 plus equals count grid of grid minus count, actually we'll do diff is equal to count grid of grid minus count grid of next grid. Part2 plus equals diff, and we can say if diff equals 0, break. I don't know, that seems, hopefully this is not too slow. It's really my only concern. So it gave us 13 very quickly. And we are definitely, oh wait, we're in a loop, but we didn't update. So here at the bottom, we need to do this, and we need to say grid is equal to next grid. Oops. Okay, so now we're iterating. -3 is definitely not the answer. So let's see, we'll do print diff. -10. Weird. How do we get that? So we're just gonna start print. Let's see. Yeah. I wonder. Makes me a little nervous. Let's do this. I don't think this is our problem, but I'm wondering if that's the case there. So then we need to come down here and say, make sure we get this all fixed in. This will be count neighbors of grid like that. Count neighbors of grid like that. What is count? Didn't know. We'll count. We'll do a breakpoint right here. And now we can say count, let's say grid. And that's not super helpful, is it? Next grid has some spaces. We could spot check some of these. So like we say, like we expect next grid will look like this. So the only one in row 0, there should be one left, and it should be 0, 1, 2, 3, 4, 5, 6, 7. So 0, 7 should be, so like already 0, 1 is in there. Oh wait, hold on. If count, shoot, I did that. I made the exact same mistake. So we'll say, that seems slow. We'll say if grid r comma c and count neighbors. So we, yeah, that's a silly mistake. I bet you there were lots of you screaming at the computer screen when you saw that. 43, that is exactly the answer. Do I need to clean up anything else? Let's see if this is too slow on input. No, 8899. Let's try give it a try. Nailed it. Oh man. So this one, pretty easy, honestly. It feels like we took way too long to do this, but it is what it is. Okay. I'm going to try it today just to make sure I do this. I'm going to start Claude here in a new window. And so we will do AOC. And I really do need to make the video where I show how I've got this set up, but that's for another day. Too busy at work right now to find time to make that. Let's see. So we are, again, I'm just going to, at least for now, I'm going to keep doing it. So we've got our makedir, which isn't going to do anything. We're going to create our AOC. We're going to get the day 4 here. We are going to get the input. We see it's already solved. Yeah. Okay. Oh, you're asking me again. Stop asking me. Do you want to proceed? Yes. I'm sure there's a Claude. I've been trying. I could just say, hey Claude, you can do everything and put it in the permissions, but that feels like slightly like not secure. And so I've been trying to like hand set the permissions it needs. But clearly I'm missing things that need to be added. It got the answers, so that was pretty quick. And now it's just calculating how long it took, which was 44 seconds. So cool. Let's check out Claude's solution and see what it did. All right, so it's got a count neighbors function. Now because it's not, I can already tell you, so it's using, so it's just going to leave the lines as it is. Well, for some reason it creates a grid that is just basically the same. And then it gets the length here for count neighbors. It does the same DR check. It's smart enough to check, make sure don't count the current spot. But then it also has to check and make sure that it's within the grid space. So it's a little bit more complicated than the count neighbors function. So part one, I'm guessing, find how many are initially accessible, and it prints the length. So it just gets find accessible will go through the full grid if the spot is on, and if count neighbors is that, it appends it to a list and it returns the list. So part one is the length of that list. That makes sense. Grid, okay, so we do grid. Accessible equals find accessible. If not accessible, if nothing's accessible. Okay, so if none of them come back accessible, break. That's a smart way to check it. You could just, well, that's fine. Now it's going to loop over the ones that are accessible, and it's going to set them in the grid. And it doesn't even have to keep. It doesn't require keeping a next grid, because it can just because of the way it does it this way. That's kind of smooth. I like that. And then it's total remove just is the length of accessible. So I like that. That's might be a little cleaner than what we did. So cool. Gonna call it here today. Claude might have beat me on part 2, but he's faster than me on all of it. But yeah, anyway, we'll be back tomorrow. Cheers. Bye.